angle whose vertex is outside the circle is called an exterior angle. And the formula for an exterior angle is A equals 1/2 times big arc minus small arc. An interior angle is an angle whose vertex is inside the circle. And the formula for it is angle equals 1/2 times big arc plus small arc. When solving for one of the angles inside of the circle, you have to keep in mind that the angle is equal to half of the arc that it opens up to. So in order to solve number 1, you need to divide the measurement of the arc by 2. To solve for the second question, you'll first have to multiply the angle by 2 and get the measurement of the arc that it opens up to. Then you'll take the number and subtract it by 360 to get the length of the larger arc.
To solve for number 3, first you have to plug in all your numbers into your equation. So you have the angle equals 1/2 big arc plus the small arc. And then you work down from there to solve the equation. So once you add what's in the parentheses, you get 242, and you multiply that by 1/2, which gives you 121, and that's your angle. For number 5, you use the same equation, but this time you're searching for the large arc. So you set up the equation, plugging everything in where it goes. And for the big arc, you just put an x, and that'll be your variable. So instead of just solving downwards as you normally would, what you have to do is you have to distribute the 1/2 into the rest of what's in the parentheses. Then you have to try to get the variable all by itself. And a way to get fractions out of the equation, if it's 1/2, you can just multiply by 2, and the 2 will cancel out, and you'll have x by itself equal to 190, and that'll be your big arc. Now this equation, we had to change some of the numbers around a bit. That way we could show how to solve for the small arc. Once again, you have the exact same equation, but you're just plugging x in to where the small arc is, instead of where the big arc was. And you'll go through the same process, but this time you would have some decimals if you do go through the same process. There's other ways to do this equation, but I personally find it easier to do it like this. So you still try to isolate x to one side all by itself. And once you get to this point, instead of multiplying by 2, the other way that you can solve for this equation is to divide by 1/2 on each side. And you'll get 51 degrees is equal to x, the small arc. Alright, so when you're working with exterior angles, you do almost the same formula. It's just instead of adding the arcs, you're going to subtract the arcs. So once again, you plug everything into the formula, which is a equals 1/2 b minus s instead of b plus s. So once again, you solve what's in the parentheses, and you work downwards from there. Now this only works when you're solving for the angle. You, as seen before, have to do different steps when you're solving for the arcs. So for example, on number 9, instead of solving for the angle, you're solving for the big arc. So as you do with every problem, you have to plug everything into the formula. And then working from there, you have to distribute 1/2 into what's in the parentheses. and then try to get x by itself. And right here, as before, you can either divide by 1/2 or, what I think is usually easier, multiply by 2. And you'll get 154 is equal to x. X. Now, on number 11, we're going to solve for the small arc. And as before, as I've said before, as with every other equation that comes before this problem, you're going to plug stuff in. So, like before, you distribute the 1/2. And then you try to isolate x. Something different that we don't usually get is right here we have 2 negative numbers. Now, if you end up with 2 negative numbers, you can divide by -1/2 if you want, or you can multiply by -2. And you'll still come to the same answer, which is 42 equals x.